Hello everyone, this is Dr. Maha Abdurrahman. I'll be solving today the organic questions part in the Cambridge IGCSE paper 4. The released paper for 2023, the organic part comes with a very completely new ideas. Let's check together going to question 6, and it's talking about alkynes. Alkynes and alkenes, if we read the question, you will find a lot of hints here given in the question. Now, alkynes and alkenes are homologous series of unsaturated hydrocarbon. They're giving you here a hint about the alkynes that it contains a triple bond. And then there's a table that's giving you information about the first 3 alkynes. Now, if you look here, the formula C2H2, which is the first alkyne, is called ethyne. And if you look here on the last part, the alkyne that contains 4 carbon is called but1-ine. This is giving you a hint about the suffix used to name the alkyne, which is the suffix -ine. So, going from there, this will give me a hint on how to name the alkyne that has 3 carbon. We know all in know what. Eth means 2, prop is 3, but is 4, and definitely meth is 1. So going from here, I would call this alkane that contains 3 carbon propine, just like propene, but because it's contained 3 bonds or triple bonds, I'm gonna call it propine. Now, if I wanna go add here the formula of the alkyne, the but1-ine that contains 4 carbon atoms, it would be very, very easy. We can just count the number of carbon, 4 carbon, and the number of hydrogen is 3, 4, 5, 6. So C4H6. I hope it was clear for this part. Let's move to B. And B is asking you to give 2 other characteristics of a member of homologous series. Compounds in the same homologous series have the same general formula. Give other 2 characteristics of members of homologous series. Now, homologous series is kind of the same family group, and those members of the same homologous series would have not only the same general formula, but they also have the same functional group. They share the same functional group, and since they share the same functional group, they basically have similar chemical properties. Physical properties is not the same, but it's showing a trend. Okay, so that's what I would write here. Deduce the general formula of alkyne. Use the information in table 6.1 to help you. Basically, we did not take a general formula of the alkyne, but we can deduce it using the formula here. The formula is given here. So if it was a C2H2, C3H4, C4H6, basically the number of hydrogen is double the number of carbon minus 2. Okay, so that's why I would deduce the general formula CnH2n minus 2. Just a reminder of the general formula of the alkane is CnH2n plus 2. For the alkene, it's CnH2n only, and for the alkyne, now we already deduced it, it's a CnH2n minus 2. These questions are kind of skills questions that you are going to use the information given and interpret the answer. Now, alkyne are unsaturated. Describe the test for unsaturation. This one, from our knowledge, we all know the test for unsaturation, which is the bromine water test. The result would be also, we all know it, which is change the orange brown color to colorless. So change brown color to colorless, or you can always write decolorize the bromine water color, the bromine water color, which is the orange brown color. Now, ethene and butene are alkenes. Draw the displayed formula for butene. Displayed formula is the formula that is showing all bonds. Don't forget this. Displayed formula is the formula that is showing all bonds. And butene. But means, let's move one by one. But means it has 4 carbon. 2 means the functional group is on carbon number 2. It's on carbon number 2. Ene means the functional group is the double bond. So basically, it's the alkene that has a double bond on carbon number 2 and it has 4 carbon atoms. I need really to analyze this before I start drawing the butene. So I'm going to draw 4 carbon, 1, 2, 3, 4. Then the carbon has to go, or the double bond, has to go on carbon number 2. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4. I need to put the double bond after carbon number 2, not before. After carbon number 2. Then I will arrange the hydrogen accordingly. So the first one will have 4 bonds, because every carbon needs to have 4 bonds around it. So 4 bonds of hydrogen, or 3 bonds of hydrogen, and the 4th one is here between the carbon. Here I would add only 1. There is a common mistake that students add 2 here. No, this is a common mistake. You can't have the carbon having 5 bonds. So I need to remove 1 bond. Okay, only 4 bonds. 1, 2, 3, 4. Okay, here as well I will add 1 carbon, 1 hydrogen only. Okay, and then on the 4th carbon add 4 more hydrogen. Okay, you can remove a numbering. I'm just numbering you can just remove a number. Okay, so this is the displayed formula of the butene. Now let's move to the other question, or it's still the same question, part II. Draw dot and cross diagram to show the molecule of ethene. Show the outer shell electrons only. Dot and cross diagram is very common question to be asked. There is no exam that doesn't have the dot and cross diagram question in it. Let's try to see how we're going to draw. You need only to show the electrons in the outer shell. Basically, I will start by drawing the 2 carbons. Okay. Now, every carbon has 4 electrons in the outer shell. So I will write that. I will draw that. 1, 2, 3, 4 for this carbon. And for the other carbon also it has 1, 2, 3, 4. Okay. Since there is a double bond, so for this carbon, that's for the first carbon, these are the 2 electrons, or the 2 pairs of electrons in the double bond. It is shared between the 2 carbon, and because it's shared, I'm gonna add them here inside the Venn diagram, because these two pair of electrons are shared between the 2 carbons. Then I have the hydrogen here is forming 1 bond, as you see. And there's another hydrogen that is also forming another bond, and I will refer to the electrons of the hydrogen with a dot, okay? So here we go. This is the hydrogen, and this is the other hydrogen. Okay, so this is the cross and the dot and cross diagram for the ethene, showing all the shared electrons. Now ethene can be converted to ethanoic acid by a two-stage process. In stage 1, ethene is converted to ethanol by catalytic addition. Suggest why stage 1 is called an addition reaction. Basically, what is very, very specific about addition reaction is that you are breaking the double bond, and then you have one product only is formed. So that's just why is it called addition reaction. I would add because it involves breaking the double bond. How would I know there was a double bond from the beginning? It's telling you that it's an ethene. Ethene has a carbon-carbon double bond. So breaking the double bond and producing one product only. A catalyst is used in stage 1. State one other condition that must be used. Now for addition reactions, there are conditions that has to be there, not only the catalyst, also there is a specific temperature and specific pressure that should be used. For steam addition, the temperature has to go above, steam is used, I can say that, steam is used, okay, and temperature has to go above 100. Now, also the atmospheric pressure should be between 20 or 200 atmospheric pressure. That's also one of the possible answers. State what must be reacted with ethanol to form ethanoic acid. Basically, this is an oxidation. We all know in oxidation of ethanol, if you do further oxidation here, it will give you the ethanoic acid, which is CH3COOH. So that's basically an oxidation. So all what you need to add is oxidizing agent, and you need to write an example. You can't just write oxidizing agent, you need to add an example. I would write example potassium manganate or acidified aqueous dichromate. So let's write potassium manganate. And because this question is 2 marks question, then you need to write it's acidified. Okay, because you need to add acid as a catalyst to the potassium manganate. So that accounts for the 2nd mark. So I would write here acidified don't forget the acidified, because many students forget this. Acidified aqueous potassium manganate. I can add as well the acidified aqueous potassium dichromate. So either or, all right? Now let's move to the other question here about the ester. Question 7. Carboxylic acid can be converted into esters. Now, propanoic acid and methanol reacts together to form an ester that has this molecular formula. Name this ester and draw the displayed formula. I mentioned before, displayed formula is the formula that shows all bonds. What's the name of the ester that resulting from reacting methanol and propanoic acid? I always start naming the ester with the name of the alcohol, then the acid. always, I will start by naming the alcohol part, then the acid part. So the acid part is, I always tell, it's like a family name. It's like the family name, and the alcohol is like the first name. Okay, so the alcohol here is methanol, so I would call the ester methyl, not methanol, methyl. Propanoic acid, it would be methyl propanoate. Methyl propanoate is the, let me correct the spelling. Methyl propanoate is the name of the ester. Then when it comes to draw the displayed formula, I do the opposite. I always like to do this cross, and then I draw the opposite. I draw the acid first, then the alcohol. So propanoate means it's the acid that has 3 carbon. So 1, 2, 3. Then I'm going to distribute the hydrogen. Here I still have 2. Don't forget, because it's an acid, it has a C double bond O, correct? Because this is basically the ester bond. This is the ester bond. And then I'm going to attach the alcohol from the other side. The methyl alcohol has only one. Meth means one, only one carbon atom. So I have hydrogen here, just to distribute the hydrogen, and this is the methyl propanoate. You need to check if the number of carbon, hydrogen, oxygen matches this molecular formula. Let's check. 1, 2, 3, 4 carbon. For the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. And oxygen to oxygen, so I'm good. This is correct. Name another ester with the same molecular formula. Another ester with the same molecular formula. I would just flip. How about that I name it the propyl methanoate. If I flip it, propyl methanoate would basically have 4 carbon, right? 8 hydrogen and 2 oxygen as well. So just flip it over. Now, can I write something like ethyl ethanoate? It still have the same 4 carbon and the same molecular formula, right? So yes, we can do this. We can also call or name the other ester ethyl ethanoate, as long as it have the same number of carbon, which it does, the same number of hydrogen, same number of oxygen. Now let's do the last question. Polyesters are polymers made from dicarboxylic acids. Name other type of organic compounds used in the formation of polyesters. Not only dicarboxylic acid, you need as well a diol. Name the type of polymerization used in manufacture of polyesters. The type of polymerization used in the manufacture of polyesters is condensation polymerization. We all know this. It's a condensation polymerization. Okay? And this concludes the organic part of this exam. I will be doing other videos to solve the other two. That's really accounts for 1/3 of the exam. I'll be doing other 2 videos to solve the other 2/3 of this exam. I didn't like to solve the whole exam in one video because it's going to be very, very long for you to watch. So I'm just going to divide each exam maybe into 2 or 3 parts. Okay, so that was, just to remind you, that was the Cambridge IGCSE exam released for 2023, paper 4 extended theory. Of course, that's the specimen paper released from Cambridge. Thank you so much for watching.